All right, so here we're looking at the region bounded by y equals negative x squared plus 4x plus 2, and y equals x squared minus 6x plus 10. We're going to take that region and we're going to revolve it about the y-axis. So what I've begun with first is just looking at the graph. So here I've graphed my two graphs on Desmos. Right, graph my two graphs here. So the negative x squared plus 4x plus 2 is the top graph, as you can see, and the bottom graph there is the green one. And again, we are revolving about the y. Right, so we're revolving this about the y-axis. So again, I want you to notice the approach with washers is going to be would be very difficult, because you'd actually have, first of all, three different parts. So you'd have to look at this region right here that's between the blue and the blue, the region right here that's just between the green and the green, and then the region right here, which is between this part of the green and this part of the blue. See, lots of problems. However, if we do shells, then we're just taking a section here between the two that's parallel to our axis. And then we would integrate along the x to get the volume about the y. And of course, we need to know our intersection points here. We can solve those algebraically, but we can see graphically this is just going to be between 1 and 4. This is going to be 1 and 4. So this time we're dealing with the second scenario where we have a top function and a bottom function. And again, as we saw, we're just going to do the difference of the two functions, still have the rest of the formula there, 2 pi x. Okay, so let's go ahead and set about doing that as we do this shell version of this problem, which would be extremely difficult and painful if we did it with washers. Okay. So first things first, our volume will be the integral of 2 pi x times the top function minus the bottom function. Top function again is our blue function, negative x squared plus 4x plus 2. Now I'm going to do one small thing to save me having to rewrite this again. The formula calls for minus the bottom function. So I'm going to go ahead as I write this out and distribute the negative through, the subtraction through, just to save me the trouble of having to write the whole thing over again. So that'll become minus x squared plus 6x and minus 10. Okay, and so dx. And so now we have it set up. Now it's just really working out the problem. So 2 pi out front, multiply through by the x after we combine like terms. So we have negative x squared will be 2x squared with the x. So integral, this is of course 1 to 4. Looks like I forgot those again. A little too ahead of myself. 1 to 4, so that's going to be negative x squared, and negative x squared will be, that's 2x squared times x, minus 2x cubed. In the middle, we're going to have a 4x and a 6x will be 10x, times x will be a 10x squared. And then 2 and minus 10 will be minus 8 to go with the x. Make that minus 8x dx. And so again, we carry the integration through. Add 1 to the exponent will be 4. So that'll be negative 2 over 4 will be negative 1/2 x to the 4th. Plus Add 1 to it, we get 3, so that'll be 10/3 x cubed minus 4x squared. And then we're evaluating that between 1 and 4. Evaluating that between 1 and 4. And when we do that, we should get 45 pi cubic units. Okay, so this is another example here. Again, just kind of showing you, again how to do the shelves. And again, this is an example where we would be very hard pressed trying to do it with washers. Very, very difficult. Very complicated as well to do it that way. So we focus here again on using shelves because it makes the most algebraic sense. Now sometimes you'll have problems where it's not the worst thing in the world to do it. Okay, and we're actually going to see an example. We'll see an example where we're actually going to do it both ways. And so sometimes it's not so bad. But then other times, as we see here, it's just really painful to try and do it using washer method. Just like there are going to be some shell problems where you're not going to want to use shelves. Okay, in fact, a lot of the ones we did in the previous section with the disc and washers were kind of optimal for disc and washers. Okay, so hopefully this gets you kind of started, and we're just going to continue. And in fact, in the next example that we look at, we're actually going to do it both ways.